Hello and welcome to the third episode in this tutorial series showing how to build a simple balsa wood discus launch glider. As you may recall, the aircraft we're building in this series is a simplified version of the one you see here. In previous episodes, we've built and assembled the wings, fuselage, and tail boom. You can find links to those videos in the iCard section as well as in this video's description. This episode will cover the construction of the tail surfaces. However, before we get into that, I want to apologize for any apparent hurriedness in this video's production, as I was a little short on time this week and couldn't do as good a job as in the other episodes. That aside, let's look at the first step for the construction of these tail surfaces. First and foremostly, of course, you'll need your 3/32 inch thick balsa wood from which your tails will be cut along with the rulers that you'll use to measure things. Of course, you'll also need your sanding block for sanding the airfoil shape into your tail surfaces, along with your knife and your pen for doing all the marking and cutting. You'll then, of course, need templates for both tail planes as well as for the horizontal stabilizer mount. As you see, I have a set of wooden templates here, but you can cut yours out from the printable plan linked in the video description, and both the wooden and the paper templates will serve the same function, so fear not. We'll now begin work on these tails by using our pen and our longer ruler to mark a center on our balsa wood sheet. We'll then use the thicker ruler to balance the sheet on its center line and see which side is lighter. Using the tail templates, we'll then mark out the shape of our tails on the lighter side of the balsa wood, hopefully thereby accessing the lightest wood in the sheet to use for our tails. As you can see, I haven't bothered to draw an elevator separation yet because that would be sanded away when I sand the airfoil anyway. I have, however, marked a center line because some of that may remain even after sanding the airfoil, provided I sand a proper high point, and that might provide me with a nice way to locate my center at further stages of construction. As you can see here, I'm marking out the horizontal stabilizer mount on the heavier, denser side of the balsa wood sheet to make sure it has as much strength as possible. Having now finished this step, we can move on to the next. We'll now use our X-Acto knife with a nice new number 11 blade to cut out very approximately the shapes of our tails. As you can see, with a little bit of editing magic, I exert barely any effort and somehow cut out both tails within seconds. There's one and there's the other. Now, as you can see here, wherever I would have had to cut a cross-grain curve, I've instead just cut a little point. This allows me to avoid damaging my part by avoiding those nasty cross-grain cuts and instead using my sanding block to carefully shave down those contours until it matches exactly the line I've drawn. As you can see, I'm doing that sanding process here to both the vertical and horizontal stabilizers. We'll now move on to what is arguably the most important step in the fabrication of these tail surfaces, which is the sanding of the airfoil shape. Now, you can see my tutorial on how to build the wings for a full description of how to sand a proper airfoil shape, because essentially, we're doing the same thing to these, merely on a smaller scale. As you can see, I've now sanded a nice semi-symmetric airfoil into this horizontal stabilizer, for which I've used 3 different sanding tools: a smooth 500 grit sanding block for smoothing down the surface, a rough sanding block for removing lots of material, and a little piece of sandpaper for smoothing out some of the edges. I'll now weigh the part and find it to be a whopping 2.05 grams, much too heavy, probably because I used such poor quality balsa wood for this demo. For your model, you should strive for around 1.7 or 1.5. I'll now airfoil the vertical stabilizer such that a little more camber is on the left side, resulting in a right tendency which will be especially strong during the launch phase of flight. This will counteract the launch roll that most small gliders are prone to. In this next step, we'll be marking out the elevator and rudder separations. So we'll use the templates for both tails, in this case I'm beginning with the vertical stabilizer, and we'll mark out the separation with our pen and then use the ruler and the X-Acto blade to score this separation lightly. We'll then slowly and carefully crack the tail along that score line such that we can clearly see where the hinge line will be. Be careful here not to completely break the 2 pieces apart. I may or may not have accidentally done that in this case. Point is, you shouldn't. Whatever the case, as you can see here, I'm using some tape and scissors to cut a strip of tape, which I'm then laying along the hinge line to act as the hinge point for the control surface. And as you can see, I'm struggling to get a nice, cleanly cut piece of tape while under the stress of being on camera, so I highly recommend you don't try filming yourself while doing this. I'll now sand a bevel to make sure the rudder can move in both directions, and the smaller the bevel the better because we only need around 20 degrees of motion, so any extra bevel is just adding unnecessary drag. I'll now complete the same exact process for the horizontal stabilizer, marking out the elevator separation with my straight edge and pen, then scoring it with my X-Acto knife and breaking the tail along that separation so I get an idea of where the hinge line is. Then I'll take my piece of tape that I've cut off camera this time and I'll lay it along the hinge line to get a nice proper hinge. Then I'll sand my bevel and that's that. And remember to always take good care while clearing off your workspace. Having properly hinged both tails, we can move on to the next step, in which we'll make the springs. Of course, you'll need some pliers and wire cutters, as well as a nice dark pen which can mark on your wire. Of course, you'll also need your wire, for which I'm using plain steel PL011 guitar string. And then, of course, you'll need your ruler too to measure out the lengths of the certain things you'll be cutting. We'll first measure and cut off a 1.5 inch length of wire. We'll then use the marker and ruler to measure 3/8 of an inch in from one end of the wire and bend that up at a 90-degree angle with the pliers. We'll then measure 3/8 of an inch in from the other side and bend that down at a 90-degree angle pointing in the opposite direction as the other leg. We'll then bend the two legs in a dimension perpendicular to the dimension in which we just bent them, such that there's an offset between the two legs of around 20 degrees. It's rather hard to describe, so how about we take a look at a picture of what that ought to look like. There, see? Simple. Sort of. We'll now simply repeat that process to make a second spring. Having finished the springs, we'll now move on to the next step. We'll now be making the control horns, the tools for which you can see here. We're going to put down a piece of scrap wood to work on top of such that we don't damage our table. Now, as you'll see, the elevator control horn will naturally have to have the same height as the elevator mount, such that the control horn is in line with the tail boom. We've now made the hole at the proper height, but we now have to sand the burr off such that there's no possibility of our control line getting frayed or cut. We've now finished the first of two control horns. Now, this design conveniently allows for both control horns to be the same exact size and height, because the height of the tail boom mount is equal to the sum of the width of the tail boom and the width of the rudder. Complex, but trust me. In this next step, we'll be gluing the control horns into the control surfaces, beginning with the vertical stabilizer control horn and surface. We'll use the vertical stabilizer template as a reference and poke the little pokey tool through to make a dent in the actual vertical stabilizer, which we can use to reference and know exactly where that control horn ought to go. You'll get what I mean when you print out your plans and see your template. We'll now press the control horn into the balsa wood to make a little dent so we know exactly where it ought to go. We'll then sand it up so it sticks nicely, we'll put some glue, and we'll stick it into place. You'll notice there's a small gap I'm leaving, which, while sacrificing some mechanical advantage, allows the control horn to not collide with the tail boom while moving to the right. We'll now use the marker and ruler to find and mark the center of one of the springs. We'll then insert the spring into the control surface such that the center of the spring is right in line with the control horn. That will ensure that the pulling force from the servo is evenly dispersed along the resistant force from the spring, making sure that the surface does not bend or warp when the servo tugs. As you can see, we now have a nice airfoiled, hinged, springy, and control horn-equipped tail surface, in other words, a finished one. So we can now move on to the other tail surface, the horizontal stabilizer, and complete the same processes for that. I don't know if there's much point to my talking you through the steps once again, but I mean, I'm doing them here on camera, the video's playing, so I've got to say something. I suppose I'll just remind you that I'm installing the control horn if you couldn't already tell, and I'm doing what I just did for the vertical stabilizer on the horizontal stabilizer, and gluing and installing and doing all the things, and then I guess it's done. Having now finished both tail surfaces, the only step left for the completion of the entire tail section is to deal with this little tail boom mount. As you can see, I'm sanding it to a little bit of an airfoil shape here, which does get somewhat nitpicky, I'm well aware. But hey, the glider police haven't caught me yet, so I persist. I'll now split my horizontal template into two pieces. You can do a similar thing by folding your paper template in half. I'll then use one of the pieces and lay it on the side opposite the control horn to mark a nice new visible center line in place of the one that got sanded away when I sanded the airfoil. On that center line, I'll then glue the horizontal stabilizer mount. And with that, we have a couple of finished tail surfaces ready to be assembled to the main airframe. I hope you enjoyed this tutorial and perhaps even built along with me. I hope you'll follow me in this series and find my next episode in which I show you how to achieve the control linkages to the servos. And as always, thanks for watching!